Hi, everybody. How's it going? Good day so far? So many fantastic talks, but I don't know about you, but I always have this problem at the multi-track conferences that I have severe FOMO of missing out on all the other talks that I can't be at. So looking forward to the day when we're able to time travel at these multi-track events. Welcome. My name is Anjana Vakil, and I am here today to talk to you about OOP, Object-Oriented Programming. Okay, quick show of hands. Raise your hand if you love OOP. Okay, quite a few folks. Fantastic. All right, how about if you hate it? Okay, many fewer hands than I was expecting, just a couple. How about if you don't really have a strong opinion and you think you might be in the wrong room? So we're going to talk a little bit about OOP, about basically, I'm hoping to take you today on a really mind-bending journey that I went on a couple years ago when I was starting to wrap my head around OOP, and I realized that I had been thinking about it and understanding its core ideas completely wrong, and in a way that was making me unable to really see the beauty and the advantages of the paradigm. So that's what we're going to get into. Hello, my name is Anjana, as I said. You can find me on Twitter at my name because I'm bad at clever internet handles. And my background is not actually in computer science. So like many of us working in tech today, I studied something in the humanities. I studied philosophy. And so in today's talk, we're going to get real philosophical. It's a little bit inspired, or how I think about things coming from this background of having studied philosophy instead of low-level computation. So if you want to, be using your time to learn something super hands-on and practical that you can take home and show your boss and put into production tomorrow, there's plenty of other talks going on right now that will help you do that. This one is going to be big picture, forest, not trees. So I will not be offended if you're not into that. But if you want to nerd out about the philosophy of programming paradigms, you are in the right place. So I used to study philosophy. I went through a few different fields before finding software development, including languages. So I also think about natural language a lot with these problems. And eventually became a software developer because it is just such a fun thing to do with your workday. So now I work at a company called Mapbox, where I work on engineering, learning, and development out of San Francisco. Anybody heard of Mapbox? Any Mapbox users? Cool, a few hands. Excellent. So Mapbox, if you don't know us, we build a location data platform to help developers like ourselves build really customized, beautiful, interactive, and live updating location-based experiences. So maps, yes, but much more beyond that. And we can talk about that later in the hallway if you want to chat maps or Mapbox. I'm happy to. This is not going to be what this talk is about. But I want to tell you really quickly, before we launch into OOP, I want to share with you some information about some communities that I really love in the tech industry, and without which I would not be standing here up on this stage in Sweden here with you today. So one of those communities is called Outreachy. Outreachy is an initiative to get more women and underrepresented minorities involved in open source by offering paid remote internships at a whole bunch of different organizations, including places like Mozilla, to work on open source projects. So it's a really fabulous initiative to help people get a foot in the door. Some projects, some internships are about coding, some are not, things like documentation or community building. So if you or someone you know is a woman or a member of an underrepresented group in tech and is looking for a way to get started with open source in a structured, mentored way, send them to outreachy.org. And if you or your company maintains an open source project and you might be interested in sponsoring an intern for 3 months, also head over to outreachy.org and find out how to get involved. It's a really fabulous initiative. I did an internship at Mozilla a few years back. Big fan of Mozilla and the open web technologies they work on. And I'm still involved with Mozilla as a member of the Moz Tech Speakers. So we're a group of community members, volunteer kind of advocates for open web technologies, not necessarily Mozilla's technologies. And this is a program where if you are interested in getting some training and support to go out and do public speaking and advocate for the open web and an open internet, then this is a program program to support you to do that. Unfortunately, the application round for this year just closed, but it's going to open again next year. So check it out at events.mozilla.org/techspeakers. OK, we're almost at the end of the plug section, I swear. The final community I want to tell you about is called the Recurse Center. So the Recurse Center is a programming retreat in New York City. Programming retreat in the sense of like a writer's retreat, but for coders. So it's a place where you can go for 6 weeks or 3 months and work on getting better at programming, whatever that means for you. It's completely unstructured, not a boot camp, no classes. It's just a place for people who are really curious and want to pursue their curiosities in the world of software and computer science. And you can check it out at recurse.com and read all about it. But what the relevance to this talk is that, so I went to the Recurse Center a few years ago. I was there during my batch, and I had come out of a couple of years of starting my software development career, as it were, or starting to learn about software development in a context of academia, of writing academic code. And I had been doing a little bit of Python scripting, and I had started learning about object-oriented Python. And when I went to the Recurse Center, I had this notion of like, OK, I know OOP, sort of. Like, I can write objects and make classes and things. But I'm not really quite clear on how to understand this paradigm in the context of other programming paradigms. So I started getting really curious about different paradigms out there. And I started thinking a lot about OOP. And it's through the community at the Recurse Center who were so generous with their time and their knowledge sharing that I came to realize that I had been thinking about OOP all wrong. I had been missing the forest for the trees. I had been understanding some of the minor ideas to be major ones and vice versa. And so that's really what I want to share with you today, is how I sort of had my mind blown, thanks to friends at the Recurse Center, when I realized that if I looked at things through a different lens, OOP became so much more powerful than I had ever imagined. So I had thought that OOP was all about these kind of things. Objects, I mean, it's in the name. Object-oriented programming, surely objects are important. Classes to make those objects, inheritance, all the different types of vehicles and whatever that you get in the textbooks, as we all know, these hierarchies, these taxonomies, and that, there are object-oriented languages like Python that I worked in, but that they're the kind of prototypical ones were things like Java or C++, which is like the object-capable version of C. Or so I thought. Then I started reading some of the links that my Recurse Center friend sent me, and I realized that this is all incidental and not even accurate in some cases, that this is not what OOP is about. So this left me with like this crisis of what does it all mean? What is OOP if it's not those things? I thought I was an object-oriented developer. Now what am I? Do I even exist? What is meaning? What is time? Pfft, right? No, just me? I'm the only one that has that when I'm typing? OK, so this is what happened. I was trying to figure out, OK, what is it then if it's not all of those fun things, if it's not inheriting different mammal classes to make your zoo? So I started reading up the work of this guy, Alan Kay. Super interesting figure. He is a good person, I thought, to try and understand object-oriented programming from, because he kind of founded it in the sense he coined the term. He was one of the primary developers or the principal developers of the language called Smalltalk, which became kind of a prototypical object-oriented language. And he was also doing this, it became important for me to understand, he was doing this with a view towards creating a world of ubiquitous personal computing. So he was really pursuing this vision where any of us, all of us of any age, of any familiarity level, could pick up a personal computer. This is him holding a prototype of the Dynabook, which was this idea of this kind of tablet-like computer with like near infinite battery life that anybody could pick up and become a productive software developer in at any level, at any age. And so it turned out that this idea of this kind of anyone can compute and we should build systems that are flexible enough to serve literally everyone's needs became or was a very important influence on the ideas behind object-oriented programming. And then I found out an even more interesting fact, which is that another important influence on the metaphor or the design of OOP was his background. Like some of us, as I said, he was not always a computer scientist. Turns out he was a biologist first. And this biology background really shaped some of the core metaphors of object-oriented programming. So this, I realized, had been my first mistake. My first oops was I had been misinterpreting the biological metaphor, or using the wrong biological metaphor. So I had actually thought that there was a pretty strong metaphor for object-oriented programming from biology, but I thought that it was coming from ideas like inheritance of traits and taxonomies of different types of species that have similar or different characteristics. But it turns out that actually the more crucial metaphor here is the notion of cells, and how cells make up tissues, and tissues make up organs, and organs make up organisms. And so the notion of something like myself, a human, as actually just being a collection of little teeny little bitty cells, and that are somewhat self-contained, and then organs, which are made up also of cells, but are also self-contained, and so on and so forth, is really crucial to the idea behind OOP. So if we're drawing a contrast between an imperative style of programming, or imperative paradigm, or procedural paradigm, the metaphor that I think has helped me understand it the most is sort of, we could think of the program as this intricate clockwork machine, where everything works in this very beautiful kind of miraculous fashion, that it's all able to, every little gear is able to hook up with every other little gear, and so on and so forth, to create a working machine. But the problem is that it's a single unit. It's not divisible. And so if one little gear is out of place, or if one little component falls out or something like that, the whole thing breaks down. Contrast that with the biological metaphor of cells. So if we think of cells in a body, each individual cell isn't crucial to my body's functioning. All of them together make up the organism, me, for example, or the tissue, the organ, whatever it is that we're thinking of. But each individual cell might die or change or mutate in some way, and all of those changes and those differences are tolerated by the system. The others compensate for it, and it creates a much more flexible, much more adaptable type of system than the clockwork image that we have of an imperative program. So this is the idea. If we want to make this a little bit more concrete, when we're talking about computers, what Alan Kay says he had in mind was that a computer would not be this indivisible sort of clockwork machine entity, and a program wouldn't be this indivisible clockwork machine entity, but rather we could think of a program as being a recursive composition almost of many tinier programs. And these are called objects. So the program itself is sort of one big object, and it's made up of many smaller objects, some of which might be made up of smaller objects, and so on and so forth. And these are all connected in some way to create the bigger picture. So this is where we start to get into the big idea here. Now, as I said before, I thought that the big idea with object-oriented programming, and I mean, hopefully you can sympathize with why I thought this, because it's in the name. I thought objects were the main thing that we should be thinking about here. Objects and the classes we use to create more objects. But it turns out that our friend Alan had some other ideas. So he actually wrote at one point, "I'm sorry that I long ago coined the term objects for this topic, because it gets many people, like Anjana," no, he didn't say that, "to focus on the lesser idea." So, if objects are the lesser idea in object-oriented programming, what is the big idea? Well, it turns out that it's the way that all of those little programs communicate. It's actually messaging. Messaging being kind of the glue that lets all of these little tiny programs communicate with each other to form a bigger program, just as cells in the body communicate with each other to form a larger system. So, messaging and, as we'll talk about a little bit later, late binding are actually the big ideas here. Now, going back to biology for a second, so if you're allowing me this metaphor of objects are cells, and cells have to work together somehow to create larger entities like tissues and organs and bodies, how does that work? How do they join forces? Well, they actually send each other messages by means of receptors in cell membranes. So this is a picture of a dopamine receptor, actually, randomly. So who knew? This is what happiness looks like. So simple. It's actually quite complex, but basically we have this notion that cells have their internal state, as it were, their internal lives, their internal organelles and things like that. And whatever goes on inside the cell is not the concern of the rest of the body, except insofar as there is this communication pathway through these receptors. So receptors being able to bind with molecules that are floating around in the outside context, or also pass molecules from inside the cell to the outside, and create that kind of protocol for communication on a molecular level between cells that allows the whole system to work. And so this means that even though we have these tiny units of cells, thanks to this protocol, this messaging protocol of molecular receptors, we are able to build a much, much, much larger system. And this is not unlike how we have many, many computers out there that are able to communicate with each other via certain protocols to form the larger system of the internet, which, ta-da, you can see here. This is a map of the internet. Again, so simple. Who knew? It fits on one slide. Not quite. But this is the idea, that through messaging, we're able to create much larger, more flexible, more scalable systems. And this is how OOP is meant to make the problem of solving complex problems in the area of computers tractable. So how does messaging work on a more code level? This is some pretty typical looking OOP code. We've got a thing, some kind of object. Then we have a dot. And after the dot, we have some method name, which when we call that, it's telling the object to execute this method do. We're passing in some information, some stuff. Now, how does this break down in terms of messaging? Well, we could consider this my line of code here. When I execute that, basically what I'm doing is I'm sending a little note to this object thing, and I'm saying, hey, if you don't mind, please, lovely object, won't you do some stuff for me? And so the recipient of the message is basically whatever's before the dot, this object, and everything after the dot is the message itself, where the message breaks down into basically the method name that I want the object to call and whatever arguments I need it to call it with. Now, the fact that we're sending this as a message becomes even more obvious in certain object-oriented languages like Ruby, for example, where I have alternatives. I can use the typical, .do method calling syntax, or I can also use a method that all objects have, which is .send, where I can pass in the method name as a symbol. So I just tell it the name of the method. So now the method name is one of the arguments that I'm passing in, and these are equivalent. So this makes it pretty clear that this is actually what's going on under the hood. Conceptually, I am sending a message to thing. Now, what thing chooses to do with that message, whether it chooses to actually listen to me and do this thing with the stuff, or whether it chooses to update something internally, or whether it chooses to, I don't know, completely ignore me, all of that we don't know yet. We'll talk about that more in a moment. And that also means that we don't know how this is going to react to different types of messages, right? So what if I ask it to do the thing with other stuff? Or what if I don't ask the thing to do the thing, but I ask a child of the thing to do the thing? Which do is it going to call? How is it going to work? Or what if I call the same? What if I send it the same message later at some other time? So this is where we get into the notion of late binding being important, where we don't know exactly what the thing is going to do when it receives my message. That's up to it. It's up to it to figure out whether it wants to even respond, whether it has to make some kind of change in light of the information I've sent it, whether it just completely ignores me and says, no thanks. And so what this allows us to do is, compared to an imperative system that's using early or static binding, where we really have to lock everything into place at compile time, and then things can get very rigid and inflexible, just like a clockwork machine. Late binding allows us to have a system that's much more flexible, much more tolerant and adaptable to the changing needs of the systems, the users. It's easier to update by changing just one or a few objects and how they respond to messages. It ideally is going to handle failures and inappropriate messages and things like that gracefully. And of course, that adds some problems that we need to look at later. But the idea here is that messaging and late binding give us the ability to create much more flexible systems. So we're not locking ourselves into place, because the only thing we know about software is that change is inevitable. So this is the idea here. And that's where we get into another thing I had been totally misunderstanding, which is the focus in object-oriented programming on beings versus behaviors. So I had thought that beings were the important thing, that objects were things, that they were nouns, and that was what was important. But it turns out that when we start thinking about things in terms of messages, what really matters is how objects behave, what they do. They're actually more like verbs, if you'll allow me the linguistic metaphor. As I said, this is what happens when you become a software developer after studying philosophy and linguistics. I can't help it, sorry. So if objects are more like verbs, really what matters is not what the object is, what it looks like, what it has inside of it, what all of the little organelles in the cell are, but how it behaves to the rest of the system. What kind of molecules does it receive? What kind of molecules does it transmit back? In which situations? What's its behavior? So the focus then, it goes from being data where in an imperative system we're locking ourselves into place by fully describing all of the data of our program, and that is what is important, to not worrying so much about the individual data and then how these individual objects are implemented and what they actually look like, but rather what do they say to each other? How do they interact? How do they behave? So yes, so when I'm making this message call, basically all that this object is, as far as I'm concerned, is whatever behavior it returns back to me. So let's say I have some really, really fantastic code that allows me to create objects that are friends, because I like friends, and I can just make as many as I want, because I'm a software developer. So I make myself some friends by initializing objects. This is some Python, but it's irrelevant. Initializing some objects that I give it a list of friends, and those are going to be the people that object is friends with. And then it has a method, isFriendOf, where if I call the method isFriendOf with the name of some friend, it will tell me whether or not it is friends with that person. So if I have a buddy who's a friend of Alan and Alonzo, and I send a message to Buddy saying, hey, tell me, are you friends with Guy? All that I care about is that Buddy responds back to me and says, no, I'm not your friend, Guy. If you get that reference, then we can talk about South Park later. In any case, this is the idea that all I care about from Buddy is that when I make this call, and that means when I send it this message, I get back a response saying, false, no, not friends. Now, we said before that I could call it using this dot method syntax, or in a language like Ruby, and forgive me the mixing of programming languages, but again, we're talking on a conceptual level. I could use a different syntax, which makes it more explicit that I am sending a message where the name of the method is just part of the content of the message. And I can move that name into the parentheses, basically, into the arguments that I am passing in. But as I said, in Ruby, send is a method available on every object. So really, this syntax becomes sort of irrelevant, and it's just kind of 5 extra characters that, like, why do I have to type them? What if I made this just look a little bit more like a regular function, where I could pass in the name of the method as the first argument to the function, and Buddy itself became a function? So if all that matters is behavior, then I could think about a friend like Buddy as all it is something that has to return the response false when I ask it if it is friends with a person whom it is not friends with. And I could do that with just a function that basically takes in the method name and takes in whatever arguments. In this case, it's going to be one name of a friend, and basically looks up the name of that method, sees if it has a corresponding functionality of corresponding behavior, which in this case it does if the method is friend of. And I have some isMyFriend function that it's going to use to figure out whether that name is in a list of friend names. And this doesn't really make sense yet, because how are we gonna, how do we associate the friends with the buddy? Like, how do we put them in together? I don't have an initializer anymore, I don't have a constructor. How do I make them be a thing that can behave with the expected behavior? Well, we can just wrap that in an outer function. Basically, these friends are going to be closures, so functions that close over some state that is basically passed in to an outer kind of constructor function, so analogous to my class from before, that's going to create a new friend, which is basically just going to be some kind of responder function that takes in a list of names and then gives you back a function that whenever you call it with a method name, meaning whenever you send it a message, it's going to respond with the appropriate behavior and return the expected value. In this case, it's going to say, no, I'm not your friend, guy. So where I'm going with this, as you may have guessed, is the biggest, I think for me, the biggest misunderstanding that I realized I had had, which was my complete misconception of the boundaries between object-oriented programming and other paradigms. So I had thought that object-oriented programming was kind of a special case of imperative programming because they both have state. And that there was this huge, epic gulf between object-oriented programming and functional programming because of all the flame wars on the internet. If people are yelling at each other, surely there must be good reasons for it, right? Turns out that, yes, okay, imperative and object-oriented programming share the notion of state, whereas functional programming is stateless. But really, if we start thinking about things in terms of behavior, in terms of the types of messages that objects are able to respond to and respond back with, then it started to look to me like the big dividing wall was more between imperative programming and both of these paradigms, and that the difference between object-oriented programming and functional programming started to dissolve a little bit in my brain. They started to look like two different ways to create these message and behavior-oriented systems. And indeed, now I don't know Smalltalk, but that's not going to stop me from putting it on my slides. Smalltalk, anybody used it? Cool, a couple of people. Okay, you can talk to them about details later. Basically, as I mentioned before, Smalltalk was this language developed by Alan Kay and others as a very sort of truly, like, through and through object-oriented language. And it's often considered one of the kind of archetypal object-oriented languages. This is how Smalltalk defines Boolean values. It defines them in terms of their behavior. So basically, a true thing is something which, if you give it an if clause and an else clause, if you give it an if path and an else path, it'll take the if path. And a false is something that will take the else path. So basically define in terms of their behavior. Does this look familiar to anybody? Does it make anyone think of anything? It didn't to me at first, but then I started learning, thanks again to friends at the Recurse Center, about the lambda calculus. It turns out that this is very similar to how Boolean values are defined in the lambda calculus, which also we could think of as a way of defining things in terms of their behavior rather than their data. And the lambda calculus, developed in the 30s or starting in the 30s by Alonzo Church, you might recognize that lambda symbol as being the logo of every functional programming language ever. The lambda calculus is kind of a fundamentally and through functional way of looking at computation. Look how similar they are. It's basically the same way of thinking about things in terms of behavior. And so it turns out that you can actually do very object-oriented programming in some very functional languages or systems. So for example, Erlang. Any Erlangers? What's the Erlangians? No? Not yet? OK, well, there is a really fun book. If you want to learn a little bit about Erlang, check out this book, Learn You Some Erlang for Great Good, which is actually inspired by the Haskell version, Learn You a Haskell for Great Good. The author, Fred Hebert, makes these great illustrations. So Erlang was a language developed by Ericsson, and by a few folks at Ericsson, including Joe Armstrong, pictured here in illustration from a great little video called Erlang the Movie, which is on YouTube. You should check it out. It was developed to handle communication, so some telephone calls, messaging, pure and simple, as it were, connecting people to each other. And it uses this model of actors who are basically, we can think of them as these little tiny blobs that are sitting there by their mailboxes waiting for messages from other actors from other parts of the program. And they're all these little, almost objects that are passing messages to and from each other and can decide how to react, or if they want to react, or what they want to do. And they can, just like cells, if one goes down, no big deal, we make a new one. And it really creates a system that is very similar to how Alan Kay describes the object-oriented systems he had in mind when developing the paradigm and developing languages like Smalltalk. However, it is still a functional language. It has immutability. It doesn't allow you to change state. For example, it doesn't allow you to change the value of a variable once you've created it. So it is both functional and object-oriented, if we think about object-oriented as being this bigger picture idea of messaging. Super interesting. Highly recommend reading about it. Another kind of interesting crossover that I wasn't aware of until one of the Øredev organizers turned me onto it is there's been some work recently in JavaScript, in the JavaScript community, to try and deal with this issue of callback hell. Any JavaScript developers? Callback hell? Sound familiar? So there's a talk by Andre Staltz, who's this RxJS developer who created something that he calls callbags. And he gave this talk this year, actually, called Callback Heaven, where he explains how they work. Recommend checking it out. But basically, it's kind of very similar to this actor message passing system that we've been talking about so far with Erlang and with the ideas of the object-oriented world of things like Smalltalk, where we're trying to deal with streams. We're trying to deal with streams of data as something that is kind of object-ish in the sense that they can talk to each other by means of messages. So they send each other signals to, OK, start subscribing. Stop sending me data. I want to stop subscribing. And it's not purely functional, but it sort of moves a little bit in that direction and makes us think a little bit more along that lines of the important thing is not what is this data, but the important thing is how do I talk to it, and what are the protocols going to be for sending those messages back and forth. So another interesting kind of crossover from the JavaScript community. And I find it quite curious that a lot of these systems, it's kind of like different areas and different communities are sort of arriving at this idea on their own timelines and in their own ways, but we keep coming back to this metaphor or this kind of big picture. And that was my kind of final aha moment or realization of what I had been misunderstanding, which was I had been misunderstanding the kind of core belief structures of object-oriented programming. So I had thought that OOP started to feel a little bit dogmatic, a little bit restrictive, like everything has to be an object, and it has to have a class, and that class has to have all these things, and it has to have the interfaces, and blah. So if I was programming for a bit in Java and started to feel a little bit restricted by the fact that I had to think in objects. And I think that's because I was thinking about it the wrong way. And also because it's entirely possible to write non-OOP code in Java. Because again, it's not about the classes and these sort of things. It's about the big picture idea. And the big picture belief here is that if we design systems in this way, then they are going to be really adaptable and resilient in the face of change. Now, whether that's we're using Alan Kay's objects, we're using Smalltalk, and we're using these UI interfaces that are built up of much smaller UI interfaces that are built up of much smaller UI interfaces that he had in mind for things like the Dynabook and personal computing. Or whether we're thinking about Erlang and its success in creating really fault-tolerant, really adaptable systems that are able to handle bajillions of phone calls and messages and things like WhatsApp being built in Erlang because of that tolerance and because of that amenability to change. or whether we're thinking about new library protocols coming out in the JavaScript community because they're finding it hard to maintain the more brittle structures that they've created so far. All of these are sort of getting at the same idea, which is that if we think about things in terms of messages and in terms of delaying the beliefs about what's going to happen when I send an object a certain message, then we will develop systems that are much more capable of handling the inevitable change and unexpected things that are going to occur. And that's at least the aspiration. Now, there are challenges getting there, but that's the aspiration. So for me, the big picture here is that this view of object-oriented programming, it comes down to the idea of hiding that complexity inside the cell, inside the object, as it were. Whatever, maybe you need state, maybe you don't, because you're in a stateless world. Maybe you have some processes going on. I don't know what you're doing inside that cell. It doesn't matter. All that complexity is hidden. And through this message passing interface, what's exposed to the outside world is the simplicity of just send me a message, and I will do what I need to do. So managing that complexity with message passing, lending us a system that's much more resilient, much more flexible, something that we can modify as we need to, as we go, and something that will scale to these like epic proportions, just as the internet has, just as the billion, I don't know, how many cells are in a human body? The billion? We'll look it up later. I should have looked up, there's so much biology theme. I'm sure somebody here knows how many cells are in a human body. We'll talk about it. Anyway, these large systems become just as simple as a small system because of this recursion, because of this breaking down into smaller and smaller self-contained units. So this, to me, and hopefully also to you, really re-inspired me to look at object-oriented programming from a completely different lens, to not worry so much about the classes and the inheritance and the mechanics of doing the whole thing and of what these objects look like, but to think about the big picture and what it means for how we build these systems. And so even on a level above code, when we think about architectures like service-oriented architectures or microservices, or having a bunch of serverless functions in the cloud all talking to each other through Kinesis streams or whatever it is, all of this comes down to this idea of messages, of scalable systems because of recursion, and of thinking about objects not in terms of what they are, but in terms of what they do. And so for me, this has been a really useful mind shift in how I think about creating my programs. And whether those objects are pure functions or whether they are little stateful chunks of state and process, doesn't really matter. All that matters is how they interact and the larger system that they're able to build. So that is pretty much my talk. There's a lot more to say about this and a lot more to read about it. I have some references here. I'll tweet out the slides. Don't worry about it. I want to give a huge thank you to the folks at the Recurse Center who helped me wrap my head around all this stuff, or I should say start to wrap my head around this stuff, because I'm still learning, as are we all. It's a constant, lifelong process. Especially David Albert and Darius Bacon, who really turned me on to a lot of the resources listed here that blew my mind wide open. And many other folks at the Recurse Center. And thanks so much to the Øredev organizers for having me here, and thank you all for coming and listening.